So we have started with the logistic regression part, right? In the last session. And we have built the model for logistic regression. And we also have discussed the theoretical part of logistic regression, right? Now we have to discuss this part, which is nothing but evaluation metrics for classification. So what are the different evaluation metrics that we have for classification? We'll just try to discuss that. So we have used accuracy score over here for the classification model, but we have different evaluation metrics that we are going to discuss. I'll just open this. Evaluation metrics for classification. Right. So why evaluation metrics are important for us? Why do we use evaluation metrics? To evaluate the performance of the model, right? For an example, to check its accuracy, check its effectiveness. So we have several evaluation metrics that we are going to study. So as we know, classification is nothing but it's all about predicting the class labels given input data, right? For an example, in binary classification, we have two possible outcomes. In multi-class classification, we have multiple outcomes, right? So very common example of binary classification that we have discussed here is spam detection. Spam detection, where the input data could be your, let's say, email text is your input data, and you have to label the data as spam or not spam. तो आपको अगर ईमेल आया है उसको स्पैम और नॉट स्पैम कैसे लेबल करते हैं, that we are going to study over here. Suppose this is a problem statement. So either spam or not spam, or positive or negative, or class 1 or class 0. So we have with us is accuracy. What do you have? We have accuracy. First evaluation metrics. So it gives you idea about the ratio of correct prediction by the total number of predictions. Ratio of correct prediction by the total number of prediction. So when any model gives you accuracy of 99%, what does that mean? You might think that the model is good, right? When the accuracy is 99%. But sometimes it is misleading. How it is misleading is in some situation, let us try to understand the example कि accuracy 99% भी कैसे mislead कर सकती है. Let's say you have a binary classification problem where model can only achieve two results. Either model can give correct predictions or incorrect predictions, right? Now imagine we have a classification task to predict if the image is dog or cat. If image is dog or cat. So as we know, we train the model, then test the model on the testing data. And once the model prediction is done from the X data, we compare prediction with the true value, right? We compare the test value with the prediction value, predicted value. So we feed the image of the dog to the model, feed the image of the dog of the dog into training. Suppose model predicts that this is a dog, right? Model predicts that this is a dog. And we compare it the prediction of the correct label. So if the model predicts that image is a अगर इसने dog predict किया तो we predict it as a correct label. If the model is it is predicted as cat, so it is a incorrect label, right? So we repeat this process for all the images in next test data, and eventually we'll have a count of correct and incorrect matches. तो ऐसे process repeat करते हैं, we repeat the process and we count the correct and incorrect matches. We count the correct and incorrect matches, right? So ऐसा बहुत कम बार रहेगा. In reality, it is very rare that incorrect and correct इसका आउटपुट सेम रहेगा. फॉर एन एग्जाम्पल 95 इनकरेक्ट है तो करेक्ट भी 95 है. ऐसा बहुत कम बार रहेगा, राइट? सो देयरफॉर वन मेट्रिक जो है एक्यूरेसी, वन मेट्रिक won't tell you the entire story. One metric won't tell you the entire story. Accuracy is useful when the target class is well balanced. When the target class is well balanced. But it is not a good choice for the unbalanced class, right? We can have 99 images for 99 accuracy, matlab kya? 99 correct images for dog and only one image for cat. So 99 correct prediction hai or one incorrect aisa. So then our model will always predict the dog and therefore we get the 99% accuracy. But in reality, data is not always balanced, such like for an example, your spam email data or credit card for fraud data, right? For medical diagnosis data. It is not balanced. So if you want to do a better evaluation, we should have full picture of model evaluation. This is what we have. So other metrics like recall, precision should also be considered, right? So ये हो गया आपका accuracy. This is your accuracy. Then moving further, we have a confusion matrix, and this is what we are going to study now. What is confusion matrix? It's a performance measurement of for the machine learning classification problem, where the output can be of two or more classes. It's a table with the combinations of predicted and actual values. So it is like this. Let us take the image of confusion matrix. This is your confusion matrix. This is your confusion matrix. So this defined as a table that is often used to refers to as this thing. Suppose we have a table like this. तो यहाँ पे actual values रहेंगे and predicted values रहेंगे, right? Actual values में suppose email में we have positive, we have negative. Predicted values में भी आपको predicted values में भी आपको पॉजिटिव है एंड निगेटिव है. तो पॉजिटिव में आपके पास सपोज एक्चुअल वैल्यूज भी पॉजिटिव है और प्रेडिक्टेड वैल्यूज भी पॉजिटिव है, तो ये इसको बोलते हैं ट्रू पॉजिटिव. एक्चुअल वैल्यू इज नेगेटिव एंड predicted value is also negative, that is true negative. ये करेक्ट प्रेडिक्शन है, राइट? एक्चुअल में भी पॉजिटिव है, प्रेडिक्टेड में भी पॉजिटिव है, एक्चुअल में भी नेगेटिव है और प्रेडिक्टेड में भी नेगेटिव है. दिस इज ट्रू प्रेडिक्शन, राइट? दिस इज करेक्ट प्रेडिक्शन. बट इनकरेक्ट कैसे हो सकता है? एक्चुअल में नेगेटिव है और प्रेडिक्टेड में पॉजिटिव है, तो इट इज फॉल्स पॉजिटिव. और एक्चुअल में पॉजिटिव है बट प्रेडिक्टेड में नेगेटिव है, दैट इज अ फॉल्स नेगेटिव. सो ये हो गया आपका. दिस इज व्हाट वी हैव फॉर कंफ्यूजन मैट्रिक्स ओवर हियर. तो दिस इज योर कंफ्यूजन मैट्रिक्स एंड इसमें ट्रू पॉजिटिव एंड ट्रू नेगेटिव, यही करेक्ट प्रेडिक्शन है. यू कैन सी इट in this figure. Predicted value is positive and it's positive. This is true prediction and this is also true prediction. And ये false positive, false negative is a false prediction. This is what we have. Now is it clear for everyone? Confusion matrix, is it clear? सो दिस इज व्हाट वी हैव फॉर कन्फ्यूजन मैट्रिक्स. तो इसके ऊपर ही उन लोगों ने फॉर्मूलाज बनाए हैं. एक्यूरेसी का फॉर्मूला क्या है? रेशियो ऑफ करेक्ट प्रेडिक्शंस बाय द टोटल नंबर ऑफ प्रेडिक्शन. तो करेक्ट प्रेडिक्शन क्या है आपके मशीन लर्निंग कन्फ्यूजन मैट्रिक्स में? ट्रू पॉजिटिव प्लस ट्रू नेगेटिव, राइट? दिस इज योर करेक्ट प्रेडिक्शन. एंड टोटल क्या है? टू टीपी, एफपी, एफएन एंड टीएन. सो डिवाइड बाय टीपी प्लस एफपी plus Tn plus Fn. This is a formula for confusion matrix. This is your formula for the confusion matrix. Second is, sorry, not confusion matrix, your accuracy. So once the confusion matrix is understood, let us take this image. So this is very common image that we generally discuss. देखो यहाँ पे, what is your problem statement? You are building a machine learning model which will predict whether the patient is pregnant or not. So यहाँ पे ट्रू निगेटिव क्या हो सकता है? दोनों निगेटिव है. ऑब्वियसली मैन कैन नॉट बी प्रेग्नेंट एंड योर मशीन लर्निंग मॉडल हैज एक्चुअल में ही इज नॉट प्रेग्नेंट एंड प्रेडिक्टेड इज आल्सो नॉट प्रेग्नेंट. So your machine learning model has predicted that this model as an this man as a not pregnant, right? But ये जो false positive है, ये this is wrong, right? False positive उसको बोलते हैं type 1 error. Just like they have given type 1 and type 2 error, your actual case is not pregnant, but machine learning model has predicted as this man as a pregnant, right? So this is error over there. Second is, this woman is, you can see this is a, she is a pregnant, actually is pregnant, but model has predicted not a pregnant. So this is also error that we have. In actual case, she is a pregnant, but model has predicted her as not a pregnant. And last but not the least is, in actual case, she is a pregnant and model has also predicted as a pregnant. So this is what we consider as the example. Now उसके बाद में है आपका third evaluation matrix as precision. And precision explains how many of the correctly predicted cases actually turned out to be positive. Correctly predicted में से कितने positive it turned out to be positive. So true positive is the positive, correct इसमें से. Correct कितने हैं आपके पास? दो ही है, true positive and true negative. उसमें से positive क्या है? True positive divided by EP plus FP. Right? So it is defined as the number of true positives divided by the number of predicted positives. Fourth is recall. It explains how many of the actual positive cases we were able to predict correctly with our model. So, how many of the actual positive cases we were able to predict correctly with our model. So it's a useful matrix when ये कब useful है? It is useful when your false negative is of higher concern than false positive. और ये कब है? जहाँ पे फॉर एग्जाम्पल मेडिकल केसेस where it doesn't matter whether we raise a false alarm, but the actual positive cases should not go undetected, right? सपोज आपको एक देखो इसमें फॉल्स नेगेटिव क्या है कि एक पेशेंट है वो सीरियस है और एक पेशेंट है वो नॉट सीरियस है, राइट? तो पेशेंट नॉट सीरियस है तभी अलार्म बजा, तो इट इज नॉट हार्म, राइट? देयर इज नो एनी हार्म, ये चलेगा बिकॉज ही इज नॉट सीरियस, बट अलार्म गलती से बज गया वहां पे. बट पेशेंट इज सीरियस and still is no alarm for this patient, so he might lose his life, right? तो ये टाइम पे रिकॉल इंपॉर्टेंट है. रिकॉल का फॉर्मूला क्या है? डिफाइंड एज द नंबर ऑफ ट्रू पॉजिटिव divided by the total number of actual positive. So recall is true positives divided by true positive plus false negative. This is the formula. And last but not the least, fifth we have is a F1 score. So what is F1 score? It is known as harmonic mean of precision and recall. So F1 is 2 times precision into recall divided by precision plus recall. So this is what we have for F1 score. So F1 score क्या करता है? प्रिसीजन का और रिकॉल का जो ड्रॉबैक है वो कवर करता है. F1 score pernicious extreme values more, and F1 score could be an effective evaluation metric in the following cases. So sixth we have is AUC ROC, receiver operator characteristics. ROC is receiver operator characteristics, and AUC is area under the curve. So देखो इसका figure if you want to take, you can take it. This figure. देखो, so from this graph, the greater the AUC area under the curve, अभी थ्रेशोल्ड सेट करते हैं 0.5, तो ये जो एरिया अंडर द कर्व रहेगा ये थ्रेशोल्ड है ना. ब्लू लाइन इज अ थ्रेशोल्ड और अ लिमिट. सो दिस इज 0.5, 50% एरिया अंडर द कर्व. मैक्सिमम कब रहेगा? व्हेन you have this area under the curve pura, it will be maximum 100%. But for this case it's EDCBA, right? This curve, तो उसका area under the curve ये shaded region है, and it is obviously greater than 0.5. तो अपन सेटल थ्रेशोल्ड ऐसा सेट करते हैं कि it should be greater than 0.5. It should be greater than 0.5. So अगर greater than 0.5 AUC रहेगा, area under the curve, if it is greater than 0.5, then it is a best fit model, a best model basically. और AUC 1 रहेगा तो that is very best, but 0.5 से ज्यादा चाहिए तो ही आपका क्लासिफिकेशन मॉडल सही रहेगा. So this is what we have for the confusion matrix, sorry, evaluation matrix for classification. You have a look at this, and if you have any questions in this, you can let me know. Yes, is it clear for everyone? right? So you have a look at this. I'll just um, share this thing with you. You go through this link which is provided over here, and we'll have a quick break of 5 minutes. It's 11:40. Let's take a break for 5 minutes. We'll be back and we'll do the hands-on after 11:45. So logistic regression project we are going to start after the break. Hi everyone. So we'll just have a quick this thing logistic regression project. Let us create a new folder and let's rename this as logistic regression project. I'll just take out the data. I'll just take the data over here. Mm, mm. I'm just uploading it on your drive so that you can have a look at that as well. Machine learning. Right. So this is our project and this is data. So I'll just download this data and I'm going to upload it. Over here. New notebook. Logistic regression project. Let's again this is important the necessary libraries. Import pandas as pd, import numpy as np, import matplotlib dot pyplot as plt, import cbon as sns, and df is equal to pd dot read underscore csv. This is our data name. So we'll just write down this and we'll just press tab to auto complete this. We are going to check the head of the data. And if you just write down df.shape, this is our 5110 rows and 12 columns. So what is our problem statement over here? We want to build the ML model, in this case logistic regression model, which will predict whether person will get stroke attack or not. Now if you just check the head of the data, here we have ID, gender, age, hypertension column. Heart disease, ever married, work type, residence type, average glucose level, BMI, smoking status, and stroke. These are the columns that we have. Now, based on this column, what is our target variable? It is to predict whether person will get stroke or not. तो stroke 1 जो है stroke 1 जो है that means person has stroke, and stroke 0 means person will not get stroke, right? So if you just check df of stroke dot value underscore counts, we can see that no stroke has 4861, but stroke has 241. No stroke का data कितना है? You have 4861 person. और stroke, जिनको stroke आ सकता है, वैसे कितने पे person है? We have 249. Now let us go with the exploratory data analysis. Let's write down SNS dot count plot for stroke column, comma data is equal to df. So this is our data. Now सेम है ये, मतलब जो अपन ने यहाँ पे लिखा वो ही प्लॉट किया काउंट प्लॉट में. Now what I want is based on the gender, will see the stroke count plot. So SNS dot count plot x is equal to stroke column, comma HU is equal to gender, comma data is equal to df, comma pellet is equal to set1. So based on the gender, we are going to see the stroke count plot. This is what we have. So if you see, red one is for male and green is for female, right? So male as compared to male, female का stroke का chances ज़्यादा है. We can see this, right? Now, if you go to the sns.count plot, you can see we have different attributes over here. These are the attributes that we have: palette, color, orient, right? These are the attributes that we have. You can add this attribute. जैसे मैंने यहाँ पे I've gone through HUE data, palette, ये सारे attributes मैंने use किए, right? You can go and add this parameters. उसका values भी क्या है? You can add this. So आपको stat add करना है तो उसमें आप ये add कर सकते हैं. Width का कौन सा भी float value आप डाल सकते हो. Dodge का कौन सा भी auto value डाल सकते हो. So you can check and add this thing. Now sns.violin plot for x is equal to stroke column, comma y is equal to page column, comma HUE is equal to gender, comma data is equal to df, comma palette is equal to set1. And then we have sns dot box plot df of stroke column. Then we'll go with the plt dot figure, fig size is equal to 10, 7. sns dot box plot x is equal to stroke, y is equal to bmi, comma HUE is equal to gender column, comma data is equal to df, comma palette is equal to, यहाँ पे winter ले रहा हूँ मैं. You can go and check plt dot title, bmi, and you'll write plt dot show over here to get this. So gender wise आपको यहाँ पे box plot किया है. We have plotted the gender wise box plot over here. मतलब मेल और फीमेल में स्ट्रोक कॉलम के लिए we have plotted the box plot. Now residence type जो है, residence type, उसके अकॉर्डिंग आपको काउंट प्लॉट चेक करना है. Count plot to check the occurrence of stroke across rural and urban areas. How we can do is sns.count plot x is equal to stroke, HU is equal to residence type, comma data is equal to df, comma pellet is equal to gnbu plt dot title resident site and plt dot show. So residence type के according we have count plot over here. So it seems urban and rural के uh, urban, if you compare urban and rural, तो इन दोनों के stroke में there is no difference. Count plot to check the occurrence of stroke by marital status. So SNS dot count plot x is equal to ever married, HUE is equal to stroke column, comma data is equal to df plt dot title marital status plt dot show. So this is count plot based on the marital status. तो ये जीरो मतलब क्या है, मतलब जीरो इज नो स्ट्रोक, वन इज स्ट्रोक, राइट. तो मैरिड जो मतलब यू कैन सी कि मैरिड यस, तो उनमें ज्यादा स्ट्रोक का चांसेस है. जस्ट एनालिसिस दैट वी आर डूइंग, राइट. सो जिनका मैरिड यस है उनका स्ट्रोक का काउंट ज्यादा है. df dot head now we'll just go with the count plot to check patients with or without heart diseases and stroke. So SNS dot count plot patients without heart disease. So X में क्या आएगा यहाँ पे अभी heart disease जो कॉलम है, और HUE में stroke आएगा, और डेटा में DF है, PLT dot title और condition PLT dot show. तो हार्ट डिसीज भी जीरो मतलब नो है और यस मतलब वन है. तो you cannot find a significant amount of conclusion over here, but still जिनको हार्ट डिसीज नो है उनको स्ट्रोक का चांस ज्यादा है, ऐसा we can say this. Now we can go with the count plot to check the occurrence of stroke by occupation. SNS dot count plot x is equal to work underscore type, comma HUE equal to stroke, comma data is equal to df and plt dot title Title is occupation. And PLT dot show. Right, so SNL dot count plot, X is equal to work type, HU is equal to stroke, data is equal to DF. Occupation wise, we are getting the stroke. So प्राइवेट में ज्यादा है, सेल्फ एम्प्लॉयड में भी थोड़ा ज्यादा है. गवर्नमेंट टाइप जो है, गवर्नमेंट जॉब उनको कम है, चिल्ड्रन और नेवर वर्क को सबसे कम है. सो वी कैन फर्स्ट किसको सबसे ज्यादा है, प्राइवेट, देन सेल्फ एम्प्लॉयड, उनको स्ट्रोक ज्यादा है, देन यू हैव गवर्नमेंट जॉब. Now we'll go with the count plot to check subjects with or without blood, sugar, and stroke. तो उसने डॉट काउंट प्लॉट एक्स रहेगा आपका ग्लूकोज लेवल, एवरेज ग्लूकोज लेवल, एंड HUE रहेगा स्ट्रोक, डेटा रहेगा DF, PhD dot title blood glucose level and PLT dot show. This takes time, that is the reason इसको बहुत टाइम लगेगा generally. So we'll just comment this. That's all. Now we'll go with the feature engineering, which we have not studied. If you see df dot head, so if you see residence type जो है उसको आपको encoding करना होगा, right? Work type है उसको भी encoding करना होगा, ever married को भी करना होगा, smoking status को भी करना होगा. So how to do this encoding? So what we'll do is we are going to write down this residence is equal to pd dot get dummies. If you remember, one hot encoding कैसे करते थे अपन? We just used to write down this, right? pd dot get dummies. और कौन से कॉलम के लिए? रेसिडेंस जो है, रेसिडेंस अंडरस्कोर टाइप कॉलम, उसके लिए we want to do the encoding. Drop underscore first is equal to true, and if you just check residence, you'll be having this thing, right? Now if you write df1, df1 is equal to pd dot concat, आपको क्या करना है? ज्वाइन करना है. क्या ज्वाइन करना है? df with residence जो अपन ने बनाया था, ये आपके डेटा फ्रेम में ऐड करना है. And you can write on axis is equal to 1 over here, df1 dot head. Now you can see कि जो रेसिडेंस कॉलम है वो जो रेसिडेंस कॉलम है अर्बन एंड नया नए कॉलम क्रिएट हुए यहाँ पे. यू कैन सी स्ट्रोक अर्बन, राइट? दिस न्यू कॉलम इज क्रिएटेड, दिस कॉलम अर्बन, बट वी वांट टू ड्रॉप दिस थिंग, राइट? रेसिडेंस टाइप अभी इसकी जरूरत नहीं, क्योंकि इसका एनकोडिंग किया अपन ने. जहाँ पे अर्बन है वहाँ पे 1 आएगा, जहाँ पे रूरल है वहाँ पे 0 आएगा. So we should drop this column. I'll just copy this and I'm going to drop it from df1. What do you want to drop? This thing, comma, axis is equal to 1, comma in place is equal to true. मतलब permanent changes चाहिए तो in place is equal to true. Now you'll go df1 is equal to this thing. So df1 में आपका residence का column का encoding successfully किया है, right? Similarly sex column के लिए we'll do the same thing. We dot get underscore dummies, df of sex column, sorry, gender column, yeah, this column, comma, drop underscore first is equal to true, df2 is equal to pd dot concat df1 comma sex column comma axis is equal to 1, and df2 dot drop gender comma axis is equal to 1, and comma in place is equal to true. And if you have to concat this, right? pd dot concat df1 with sex comma axis is equal to 1, and you'll drop the df2 dot drop gender comma axis is equal to 1, comma in place is equal to true. Then you are going to do this. So gender column के लिए भी we have successfully done this encoding. Now we ever married के लिए encoding करना होगा, तो वो कैसे करेंगे? marital status is equal to pd dot get underscore dummies if of ever married. If you write down marital status, मार्शियल लिखा है क्या? नहीं, मैरिटल लिखना था. Marital status, this is your encoding, right? Now same thing you have to do. You have to drop this same जो यहाँ पे किया था same. So df2 dot drop. What you want to drop? You want to drop ever married column. Comma access is equal to 1. Comma in place is equal to true. And then you will write on df3 is equal to pd dot concat df2 comma marital status comma access is equal to 1. And then df3 dot head. Right? Now it's done for this thing. Smoking status के लिए करना होगा. You can do it for smoking status. So let's create new column smoking is equal to pd dot get underscore dummies df2 में जो smoking status था drop underscore first is equal to true. And if you just check smoking, this is a smoking column. Now you have to drop this df3 dot drop. You want to drop smoking status. My access is equal to 1. My in place is equal to true. df4 is equal to pd dot concat df3 comma smoking comma access is equal to 1. Then if you check head of your df4, this is your head, right? Now you are going to write down working is equal to pd dot get underscore dummies df3 work underscore type drop underscore first is equal to true. And if you write on working, this is your working column df3 dot drop work underscore type comma access is equal to 1 comma in place is equal to true. df5 is equal to pd dot concat df4 comma working comma access is equal to 1. Then df5 dot drop work type comma access is equal to 1 in place is equal to true. Then you'll write on df5 dot head. So you can see कि हर एक column का encoding अभी हो गया है, right? Now you'll use this df5 in your data for model building. So यहाँ पे कौन सा मॉडल यूज कर रहे हैं? लॉजिस्टिक रिग्रेशन. So it's उसका पैकेज है from sklearn dot linear underscore model. Linear underscore model import logistic regression. If you run this, now इसमें ID is not important, right? ID का कुछ significance ही नहीं है वहाँ पे. Is it important? It's not important. We can drop that. So df5 dot drop ID column comma x is equal to 1 comma n plus is equal to true. df5 dot drop na in place is equal to true. null values drop kar rahe, and now we are just checking null values. Do we have any null values or not? So isNA dot sum. So we don't have any null values. Now we'll divide your data into x and y. So capital X में क्या रहता है हमेशा? You have independent variable. So you are going to drop the target variable over here. X is equal to 1. In X, what do you have? In X, you have all the independent variables. In Y, what do you have? You have target variables. Right? Now you are going to do the trend test split. उसके लिए आपको package लगेगा trend test split का. So I'll just add heading as trend test split from sklearn dot model underscore selection import trend underscore test underscore split. If you do this, now you can do the trend test split. How we generally do the trend test split? You write x trend from x test from y trend y test is equal to trend test split package name capital XY comma test underscore size is equal to 0.3 comma random underscore state is equal to 3 from sklearn dot linear underscore model. ये तो हो गया ना package. Now first step of model building is to object creation. Now to create the object, we write down model is equal to the package name logistic regression. Open and close bracket. Step 2 is model fitting. So model dot fit. You always fit it on x trend and y trend. Step 3. What is step 3? Model prediction. So model dot y underscore pred is equal to model dot predict y. What do we use? We use x test to predict the model, right? So x underscore test y pred is equal to, and you have step 4 model evaluation. In that you write you should use the evaluation metrics. So from sklearn dot metrics import accuracy score comma classification report. So you'll print this, print classification report between y test and y. So you have precision, recall, F1 score, and support. And if you write down model dot score x underscore test comma y underscore test, you can get the accuracy score over there. Or simply you can write down accuracy score between y test and y pred. So it's 95.85, right? और अगर आपको confusion matrix चाहिए तो आप वो भी लिख सकते हो. You want confusion matrix, तो उसके लिए पैकेज लगेगा from sklearn dot metrics import confusion matrix. SNS dot heat map. We have confusion underscore matrix return y test and y break. My not is equal to true. My C map is equal to whatever it is. FMT is equal to PLD dot title. Title है confusion matrix. And then you'll write down PLD dot show to get the output. So ये है confusion matrix. And if you have just not understood this, what I have done over here. So if you go to the confusion matrix, SNS dot heat map, you will get the whatever I've used over here, y test, y parade. Then anode, anode क्या है, C map क्या है, you'll get it over here. The C map, anode. तो ये सारे arguments है जो आप पास कर सकते हैं. This is a confusion matrix. So this sums up your logistic regression project, जिसमें accuracy आपका आ रहा है 95%. What we are doing is we are building a machine learning model which will classify, which will predict whether person will get stroke or not. Yes, do you have any questions in this now? Is it clear to everyone? Is it clear to everyone? So we have covered this thing, confusion matrix, sorry, evaluation matrix, and we have covered the logistic regression project. So we'll stop here for the day. I'll just give this thing to you on your drive. In tomorrow's session, we are going to, not tomorrow, in on Monday. So what I'll do is I'll give it to you on your drive. Not confusion matrix. Evaluation matrix for classification. Yes, anybody have any questions in this? In next session, we'll go with the next machine learning model, which is your decision tree. Right. So is it clear for everyone? Abhay, Aditya, Atul, Gautam, Japuji, Pianshu, Prashant, Vaibhav and Vinay. All right, then we'll stop here for the day. If you want to ask anything, you can ask. I'll wait for 5 minutes. If you have any questions, doubts, you can ask. Yes, Vinay, I'm getting an attribute error in this. What is your error? Acha, you can if you want to share your screen, you can share. I'll just help you out. Option not enabled. Hmm. Yes, Vipul. Uh, yes, Vinay, you can go share. Computers to X is equal to stroke, heart disease का है आपका. Just a minute. हम्म एक्स इज इक्वल टू स्ट्रोक नहीं चाहिए, एक्स इक्वल टू हार्ट डिसीज चाहिए. देर यू हैव रिटन एक्स इक्वल टू स्ट्रोक ना, तो एक्स इक्वल टू हार्ट डिसीज चाहिए, एंड एच यू इज इक्वल टू स्ट्रोक चाहिए. रिस्टार्ट एंड रन ऑल करो उसको. ठीक है, ये मंडे को सॉल्व करते फिर, राइट. विल सॉल्व दिस ऑन मंडे. ऑल राइट, थैंक यू, बाय.